Something funny is I just made this entire video and then realized it hadn't recorded any of my audio. So here's a second time of me talking about the intermediate value theorem. Woo! Okay, so we have four tables of values here, okay? And it's saying, according to these tables, where are the zeros? So we're going to just assume that these are all examples of polynomial functions. And what I'm asking you guys to do is identify between what two x values must there be a zero. I'm not saying to find the exact one, but just the interval where it must occur. So go ahead, really look at the tables, and then let's see how you did. Okay, so let's see how you did here. So for this first table, there must be zeros between -4 and -3, 0 and 1. There's actually 2 on this one. For this one down here, this bottom left, there has to be 0 between 3, 4. Here there must be 0 between -7 and -6. And then this last one, there must be 0 between x's 1 and 2. Okay, so let's think about why this must be. Notice what's happening. I try to highlight this to make it a little bit more obvious, but what's happening between -4 and -3? Let's take a look at our y values here. Notice that there's a change in sign of our y values. They're either going from positive to negative or negative to positive. And if that's what's happening on my graph, think about it. It's going from underneath the x-axis to above or above to underneath. At some point, if it's continuous, it must cross the x-axis, hence why there must be a 0. So let's figure out how this is related to the intermediate value theorem, which is a theorem that'll be really important to us in calculus. It says, if f is continuous on the closed interval a to b, okay, so function, it's continuous, so there's no holes, no asymptotes, no jumps, nothing like that. And k is any number between the y value for a and the y value for b. Then there is at least one number c in the closed interval a to b such that f of c equals k. Now, I know that's very wordy, and you're probably wondering, what does that have to do with the thing that we just talked about before? But maybe this will help us understand it better. So here's a graph. I have my interval a to b. The function f is continuous on this interval. I just made it up. Here's my y value for a and my y value for b. So what the intermediate value theorem says, that there must be some value k such that, so this value k is between f of a and f of b, then there's at least one number in c, so anywhere in this interval between a and b, let's go here, such that f of c equals k. Okay, so that's what that intermediate value theorem says, which is very similar to what I was explaining on this page about how if we cross from from above the x-axis to below, there must be some value where we cross at 0. So, same idea.